In this question, we're being asked to work with information from the chart here, and the chart is to do with stopping distances of cars travelling at various different speeds. And we've been presented with an idea, and the idea that we're exploring is that the idea is that if the speed is doubled, then the braking distance will go up by a factor of 4. In other words, if the car's going twice as quickly, it will take 4 times as great a distance for the car to brake to rest. So we need to be able to interpret information from the table here. Well, on this table, on this chart, on the left hand side, clearly those are the speeds. We need to be able to distinguish between the figure in white is the thinking distance, and the figure in black is the braking distance. So it's the braking distance that we're particularly interested in here. This other row of set of figures over here, that's simply the sum total of the thinking distance and the braking distance. So that's the total stopping distance. It's the braking distance that we're interested in here. So if we're talking about doubling the speed and seeing what difference that makes to the braking distance, well, let's have a look at 2 values of the speed, one of which is double the other. So we could look at, for example, 20 and 40, because 40 is obviously double 20. So if we double the speed, go from 20 to 40, does the braking distance increase by a factor of 4? Well, as we can see, the braking distance is going from 6 to 24. 6 times 4 is 24. So in that case, yes, that's perfectly true, that the braking distance is increased by a factor of 4. So certainly that set of data would indicate that. So let's start to compose an answer about this. So we can say, using the figures for 20 and 40 mph, this shows that the braking distance increases by a factor of 4. However, that doesn't automatically prove that the pattern works throughout. So let's see if we can pick out another set of data. Well, having done 20 to 40, another set that we could use is 30 to 60, because if the car was travelling at 30 and it now doubles that to 60, let's see what the effect here is on the braking distance. At 30 miles an hour, the braking distance is 14 metres. At 60 miles an hour, it's 55 metres. Now, 4 times 14 is 56, so it's not exactly 4 times, but it's very close. So we can now add to our answer and say, using the figures for 30 and 60 miles per hour, we can see that the braking distance increases by a factor close to 4. So we've acknowledged that it's not identically 4 times as great, but we've also shown that we understand that it's very close, and that should be enough to get us both of the available marks.